Hello everyone. In this video we're going to continue our discussion about polymorphism and we're going to talk about overriding and virtual methods. So previously we talked about how polymorphism applies to overloading. On the other side of polymorphism we have overriding of virtual methods. Now you saw overriding with abstract classes and methods in the videos on inheritance. The difference between a virtual and abstract method is that an abstract method defines a return type and parameters, but the programmer has to define a body for the function and is required to do so in any inheriting classes. So I basically define everything about the method, the entirety of a signature, except for what the function does when it comes to abstract methods. Then, in any class that inherits from an abstract class, I must define the body of those abstract methods. Let's quickly review abstract methods. Let's go ahead and create a basic example here. Abstract class, abstract examples, and then we define our abstract method. We do so by giving it the keyword abstract. Now remember, if a class contains abstract methods, then it itself must be abstract. So because add is an abstract method, the abstract examples class must be abstract. So we've gone ahead and we have defined our abstract method here. It is public, it is abstract, it returns an int, it is named add, and it takes in two parameters, int x and int y. Now, in our derived class, go ahead, abstract examples child, and we're going to have it inherit from abstract examples. Now, immediately you'll get an error when you create it saying abstract examples child does not implement inherited abstract member abstract examples.add. So it's telling us we have to go ahead and define a version of this method. Now, we have to go ahead and use the override keyword to make it clear that we are intentionally overriding the base class's implementation of this. And it tries to help us out here and tell us, all right, I know what you need for the function name and the parameters. Okay. Straightforward example here. So this is how abstract is set up. With an abstract method, you don't define a body. You just define that the method exists, its return type, and its parameters. You then, in an inheriting class, must go ahead and define the body of the method. And instead of having the abstract keyword on the name of the and the signature of the method, you go ahead and have the override keyword. With virtual methods, you don't have to redefine them. They're already fully defined in the base class, and only if you choose to do so do you have to redefine the bodies of the derived class. The return type, name, and parameters must match between the base and derived classes implementations, but the bodies of the methods may be different. So let's go ahead and I'm going to push the abstract examples to the bottom so that we can focus on our overriding examples. So we've got class overriding examples, public virtual, int add, and return vs.sum. Okay. So we've gone ahead and we've defined a class called overriding examples, and we have defined a method called add. Now notice two things here. First, in our class, we didn't have to give any special keywords to the class signature. It's just class. It's a class and it has a method. That method is marked as virtual. We still go ahead and define the return type, the name, the parameters, but we also define the body. So overriding examples has a method called add. You can call this method. Overriding examples, OE equals new, OE.add. And there it goes. It wants an IEnumerable of a bunch of integers. Now let's go ahead and let's create our derived class. Class overriding examples child. Overriding examples. Now right off the bat, notice the difference between the abstract and when I'm using virtual. I'm not getting any warnings having not defined add in the derived class. That's because I don't have to. Marking the method as virtual means that it can be overridden. It doesn't mean it has to be. Overriding examples child has a method. That method is add. It will go ahead and call the base class's method. Let's go ahead and to see that. Overriding examples child, OEC equals new OEC.add. And there it is. It exists. It wants to go ahead and for you to pass it an IEnumerable of int. It will go ahead and you'll see right here is calling the overriding examples.add method. So the overriding examples child object is calling the overriding examples.add method. So far, just like if this wasn't marked as virtual, this class has access to all the classes of its base class, of all the methods of its base class. Now, let's say I do want to go ahead and replace the add method in my derived class. Because it is marked as virtual, I can do that. This is the polymorphism part of things. Public override. Again, I have to use the override keyword to say, I am overriding the existing method from the base class. Now, it'll go ahead and IntelliSense will auto-populate if you see it and you press tab. Now, what's going on right here is it automatically saying, hey, I know you just tried to go ahead and define an override of your base class's implementation of the add method. Since you haven't yet, as the programmer, written anything, I'm going to go ahead and help you out here. I'm going to fill in everything you need, okay, which is the same. These are both exactly the same with the exception of the keyword virtual versus override. And you have to return an int, so I'm going to give you a return. And I'm going to say base.add vs. Now, what this is saying is I'm going to look at the base class. And that, in this case, that would be overriding examples and call its add method. I know that you are going to redefine the base class's add method. Until you do so, it's auto-populating the code to just say, hey, in case you don't ever write this or you aren't going to write this right now, default to using the base class's implementation. The base keyword, as you've seen in the inheritance videos in the past, is how you go ahead and from a derived class access your base class, the one that you've inherited from. Now, if I were to say, okay, I'm ready to write this method, I want it to be different in some way, I could go ahead and say vs.sum times 20. I could also go ahead and instead say for each var item in vs, and I could define an int before that, int x equals 0, and then say x plus equals item. And then I want to return whatever x is the total of. Notice two very different methods here. Same signature with the exception of virtual versus override, but they both return an int. They have the same name. Okay? One is the derived class from the base. Now if I go up here and I call the child's add method, you'll see it saying, hey, you want to call overriding examples child.add, as opposed to before where it said the overriding examples.add method when I hadn't yet defined an override. And that covers the two core topics related to polymorphism.